I remember reading a long time ago that the second hole is the hardest to dig. This week we're going to fix this thing which broke. This is my roommate's chess clock, SciTech Competition Game Clock. A timer you use when you're playing chess with a time limit. You play the game as normal, but if your clock runs to 0, you lose automatically. Apparently someone at my roommate's work knocked this off the table and broke it. These buttons don't work anymore. They're both permanently depressed. Sorry, buttons. Here's the deal. When these buttons are working, you're supposed to be able to push one and have the other pop up. So that means there must be some sort of mechanism here which controls their relative position. What I think happened is when it fell, it landed on both of these buttons at the same time and snapped the mechanisms. Let's talk about what I think this part looks like. I think it looks something like this. I'm just going to call this part the button beam. Here's the beam. I think it's going to be hinged in the center here, and on each end have some sort of attachment to the button. I think that this button will slide in some sort of channel to keep its motion vertical. These dotted lines indicate the location of the cross section, and the arrows show which way we're looking. Alright, I think that the button beam is going to have an I-shaped cross section. To talk more about the I-shape, let's think about how this beam will bend. Because of symmetry, we can look at each half of this beam as a cantilevered beam. You have a beam that's extending out from a surface with no extra supports. It's just firmly attached in one place. This beam is going to be loaded at the hinge here. So what we have here is a cantilevered beam with a point load on the end. Whenever you have a load on a cantilevered beam, the material in the beam is going to be stretched in some areas and compressed in other areas. And this tension and compression is going to create stress that will work to resist the torque generated by the point load. The way it works out is that the bottom portion of the beam, this portion here, is under compression, where this portion on top is under tension. Take a look at this beam as I bend it. As I bend this beam, you can see the length on this side is being shortened, whereas the length on the top is being lengthened. So this part is under compression and this part is under tension. There's actually a plane in the center where you have the transition from compression over to tension. And this part is actually under no stress. As far as it's concerned, it is not even being loaded. You want to try and maximize the amount of material in the high compression and high tension areas. You'll get more bang for your buck if you put material there. So that is where this I-shape comes from. So over here, the load exerts almost no moment or torque stress. Towards the mounting point, it exerts the most torque or moment stress. You have to have a stronger beam the farther away you get from the load. That brings me to my second point, which is the cross-section down here. This section, taken closer to the cantilever mount, is going to be taller, which will make it better at resisting this bending stress. That's our short lesson. Let's try and fix this. Alright, party people, we're going to take it apart now. I think that they hid the screws underneath the foot pads. Alright, because of some technical difficulties, we've lost all the footage up until this point. So I guess we'll just have to carry on. Anywho, I tore this whole thing down. I talked about where to look for screws. I talked about gently pulling it apart. I had to take everything out to get at the I-beam here. The button beam did have an I-shaped cross section. However, it did not get thicker as it went towards the center. But it did end up breaking right here, which is the point farthest away from the button load. where the stress in the beam was the highest. I used super glue to hold the thing together, and then used epoxy to really make a solid joint, and I put epoxy on both sides so that it would pull on the broken beam evenly. While I was taking it apart, I broke this guy. This is the piezo crystal that makes buzzing sounds, and this is kind of like a really important part of a stopwatch. So I went to my local hackerspace and I found this replacement. So what I'm going to do now is try to put this replacement on, test this thing to make sure it works, and then put it all back together. This is a DC power supply, and right now it is acting as the batteries, supplying power to these two wires. It's supplying 3 volts, which is consistent with 2C batteries. And I'm just checking to make sure everything works. I've set this timer for 15 and this timer for 3 minutes. And if I push here, then my timer starts. If I push here, the opponent's timer starts. Let's send it back my way. Notice how the light turns green. What I want to figure out now is how to install this guy. I couldn't tell what was the polarity of the old piezo, so I'm going to get the buzzer going and then use the multimeter to measure which way the voltage is, and then I'll solder the red wire to the high voltage and the black wire to the low voltage. This clock has 3 seconds left. I'm going to send it down that way. 3, 2, 1, and the light turns red. This flashes. The piezo terminals on the other side should be silently having some sort of voltage, so let's try and measure it. Can't see the clock anymore, but I can see this flashing light, so I know the buzzer's going. Now we measure the terminals. 0 volts. Okay, I've got it. It beeps whenever you switch turns. So I'm probing it right now, and then I push this thing, and then the voltage will jump up to 200 millivolts. Ah, there you go. I'll do it the other direction now. This is really hard. Boom! This is telling me that the high voltage is this joint closer to me, and the low voltage is that joint farther away. So now I can solder the buzzer into place. Okay, now let's test it again with the buzzer in. It's alive! All right. What a relief. Okay, now I'm just gonna put it all back together. Okay, now the final test is to test it with batteries but open. Make sure everything's alright. I don't want to break it now. And it works! I hear power. Off. On. And there she is. Almost good as new.